so much for being here. For those I haven't met before, I'm Aaron Gunderson with PHMass, Massachusetts. Some of you I recognize from all our past events, and I do see some new faces here, which is good. I think that's one of the reasons we wanted to do another in-person meeting. We used to do these pretty regularly. In fact, we did them every month here in either this room or one of the other ones in this BSA space. When COVID hit, we kind of put that pause on that and started doing virtual events. And in the last year or so, we've been going back to doing some in person every once in a while. But this is our first one, I think, for the year. It might actually be our first one this year in 2023, which is surprising, but it is. So it's nice to see so many people actually come out and turn out for it. It's a bit of an experiment for us. We're trying to see, how many people come to an event like this in person versus how many we get when we do our virtual events. We're going to experiment in future months with doing kind of a hybrid, so we can do in person and kind of remote at the same time. But we did miss doing some of the networking stuff. So I'm really glad so many people were here right at 5:30 to start with that. If you haven't filled out the sign-in sheet back there, please do before you leave, because we do want to know who's here versus who registers, so we kind of get a sense of what the turnout is. And feel free to send us some feedback if you want to let us know if you like in-person stuff, want us to keep doing this, do more virtual meetings. So I have a few updates I'm gonna go through here, and then I'm going to turn things over to our feature presenter for the night, David Solomon, who's right here, who came up from Pennsylvania to visit us here. He's been up in Massachusetts in the past, and we're excited to welcome him back. So I have a few things to go through. Oh, let's see if I can actually change the slides here. So first, I want to call out the Mass Save Passive House and All Electric Training Program for helping to sponsor a lot of the events that we put on. We've been putting on workshops and lunch and learns with this program now going on 5 years. And I have a couple that are coming up, but I want to make sure folks are aware what the incentives are for these. We do have some new faces here, so maybe you guys haven't seen these yet. These have been around for a long time. Now, again, going on 5 years for these incentives. Sorry, I'm going to go one slide further. I'll come back to that one for these incentives here. But these are for passive house projects, multifamily residential projects of 5 units or more qualify for these incentives. When this rolled out, we had one multifamily passive house project in Massachusetts that was completed. There's now over 12,000 units registered in this program. So pretty exciting growth. Take advantage of this up to $3,000 per unit total. You can get a feasibility study covered as well. I mean, it's a pretty great program. So anybody who's working on a multifamily project, 5 units or more, please contact Mass Save about this. And then I'm going to go back to this slide, which is about the all electric incentive. So this is for those projects that don't fit the 5 plus units. This is 1 to 4. So this doesn't require passive house. It's based on a HERS score and energy performance. So some different metrics. But it's pretty similar energy performance. So a HERS score of 35 to a passive house project. But if you're looking at a 1 to 4 unit residential project, explore this. There are some requirements for making steps towards electrification. But again, some pretty amazing incentives, $2,500 for a single family project that hits this. So I want to thank Mass Save for rolling out these incentives and keeping them in place. Contact us, email about training opportunities through the Passive House program. A couple upcoming ones that we have. So they're the end of this month on the 26th, we're doing a case study on all electric homes. So Steve Demetric, somebody who actually used to be a board member of Passive House Massachusetts and now does a lot of work in Rhode Island. He's going to be presenting on some cost-effective passive house projects on the residential scale, single family scale. So definitely tune in for that one. You can find all the registration details on our website, so phmass.org, if you're wondering where you can go for all of these events. Just go there, you can sign up for these, but this is going to be on Zoom. And I just like to mention this every time, give us an update. One of the reasons I think we have a lot of new faces here. Passive house is now a part of the building code in the state. It's an alternative pathway into the stretch code, and it's a requirement for large multifamily buildings in the opt-in code. Here's where things stand right now. So 4 towns have actually put this into effect: Brookline, Cambridge, Somerville, and Watertown. We've got a whole host of other ones that will have this go into effect at the beginning of next year. But here's the up-to-date map from the DOER. You can see a lot of communities are starting to opt into this. We know more are going to be this fall as well. So kind of exciting times here for Passive House. Those are all the things that I have to say tonight. So I'm going to go ahead and pass things off. David, coming up here.
Thank you. Thank you all for coming out tonight. Thank you, Aaron and Passive House Massachusetts, and to the BSA for hosting me. It's great to be back up here. It's been a few years. I think the last time I was scheduled to come back up was right before the pandemic. It was probably like March of 2020, and we called it off and ended up making it virtual, but it's fantastic to be here in person. So thank you all again. So this presentation is approved by PHMass for CEUs. And so the last slide has the code. It's their way of make sure you stay till the end. I also submitted this presentation to PHI for CEUs. Unfortunately, have not heard back from them yet. I expect that I will. And once I get that confirmation, I'll give Aaron the information, he can distribute it. Yeah, so quick show of hands before we get started, just so I know who I'm talking to. How many architects are in the room? And how many developers are in the room? And how many engineers? Let's start with structural engineers. Any structural engineers? No? Mechanical, electrical, plumbing engineers? Nobody? Okay. How about people who work in government and other like municipal? Yep, okay. How about homeowners? Any just like generally interested people? Yeah, okay.
Take one for general contractors.
Contractors? Sorry, okay, good. Contractors, manufacturers, great. Who else am I missing here? All right, and how about, let me try to, what's that?
Manufacturers.
We got manufacturers, we got some manufacturers back there too, right?
Sustainability consultants.
Sustainability consultants, great. And how about, let me try to gauge everybody's experience level in passive house. Who has never done a passive house before? Okay, how about like 1 to 5 passive houses? More than that? Great, cool. Well, what I'm going to talk about today is about integrating passive house methodology into the design and construction process. And this is a very broad conversation. And my hope is that whether you have no experience or a lot of experience, you still get something valuable out of this talk, and which it's a challenge, but that's my hope. And we'll have time for Q&A afterwards. I prefer that everybody holds questions. However, if I say something that's really confusing, feel free to interrupt. But if you can, let's hold questions to the end. So my name is David Solomon. I work with a company called Revision Architecture. We're based in Philadelphia. And we're a little bit unique among firms because we have 2 different studios. One, we have a high performance architecture studio where we do full service architecture, right? We do single family homes, multifamily, we do commercial, educational, institutional, agricultural, and the thing that ties them all together is sustainability. And that, of course, that will actually change quite a bit depending on the project parameters and scope, location, and budget, and interest of the owners. But sustainability in all of its manifestations is really kind of what ties all of our projects together. And then we have a second studio, which is our sustainability consulting studio. And they're just a really great crack team of consultants that, I'll talk more about those rating systems in a minute. We've consulted on, frankly, most sustainability rating systems. And then the other thing that we do is we do community engagement. And so we will actually like work with municipalities, we'll hold design charrettes, we can help community groups to define their sustainability goals and define what good looks like for them. And so, in short, right, our mission as a firm is to remove the barriers to sustainability really at all scales. So this is our team. And, as I said, we work across a whole lot of different rating systems. And there's more than this. And sometimes we even help clients create their own like bespoke ratings, sustainability standards. We've done that for a couple of universities. But the really good thing about working across this really broad spectrum of different rating systems is that we can take the things that we learn from one rating system and bring it to another. So for example, like we're experts, frankly, with Living Building Challenge. But you know, the secret with achieving the energy goals for Living Building Challenge is to actually just build a passive house, right? And then with Passive House, right, one of the things that's really interesting to see is how really both flavors of Passive House are starting to integrate some of the lessons from like say LBC and WELL in regards to embodied carbon and material toxicity, right? So we're seeing cross-pollination just across the rating systems in general. And then when we consult on them or when we use them in our own projects, we're always trying to incorporate the lessons that we learn across all of them. So a little bit about me. I'm a registered architect and I'm a sustainability consultant. I actually sort of started my career here in Boston when I was about maybe 19. I lived in Dorchester. I had a job, my first construction job was in Lexington. We tore down this old house, rebuilt it. I worked for a concrete mason, so I've been in most of the basements around here. And I had an amazing time up here. I love living up here. So I did my first training, my first Passive House training with PHI in 2014 and earned my CPhD. And then a little while later, I started consulting on FIAS projects and Wookie training in 2016. And then in 2018, I took their trainers training and got my CPHC officially. And I also will consult on projects that need daylighting analysis as well as envelope enclosure help. And so these are some of the projects that we've done, both that we've designed and consulted on. So these three up top here were designed by Revision. The first one is a back laser. No. The first one is a single family row house that was certified under PHI. The middle one is a building for Muhlenberg College. It consists of classrooms, offices, and art studios. And that one is going through the FIAS certification process. And then the one on the end here is it's kind of a very unique one for us. It was designed to look like it was 200 years old. It was really designed to last at least 200 years, and yet it still uses state-of-the-art prefabrication, panelization processes. All the doors and windows were installed in the factory, craned in onto site. But you know, it has a real stone facade, and anyway, kind of pretty unique. Also, Passive House certified. The one on the lower left-hand corner is was actually one of my first Passive House projects. That was a senior housing project, and then this one is under construction. And sorry, these two, just to be clear, these were ones that we consulted on. And this last one's still under construction, but that is a dormitory for the Solbury School in Solbury, Pennsylvania. Uh-oh. I think the batteries just gave up. That's all right. Is this gonna, can I use this?
I think you just have to use the arrows.
Just the arrows?
Sorry,
Okay,
yeah.
that's fine. No worries. I'm not going far. So, all right, it's a Passive House, right? I just want to make the point that I am going to be talking, there's a lot in here that is kind of FIAS specific, but really what I'm talking about should still be applicable to PHI folks as well. I'm completely agnostic. I actually founded a Passive House organization, much like this one. We did it intentionally to be system agnostic because we had people that trained in both. And, you know, our goal is Passive House as opposed to, you know, selling one particular version or another. And really, I think that maybe the most crucial point is even if you're not doing a Passive House at all, even if you're not seeking certification, everything that I'm going to talk about is still relevant Because if you implement passive house methodology, you are going to have a better building regardless of certification. Certification's great, but it's the details and the methods, I think, that are most important. So, there are two phases of design, right? To get to a certified project. There's a design phase certification, there's a construction phase certification, and those two combined are what gets you to a final certified project. So as just an overview of what we're going to talk about, during the design phase certification, we're going to talk about setting the schedule and the things that change when you're doing a passive house project versus a typical project. We're going to talk a little bit about how those passive house benchmarks affect the schedule. We're going to talk about construction phase certification and the verification process. Try to demystify that. I find that that's actually something that tends to surprise a lot of people, and that is a FIA-specific requirement, right? But a lot of people are like, wait, we're doing passive house. Why do we have to do Energy Star? What does that mean, right? So I want to take a little bit and demystify that. We'll talk about some of the testing parameters as well. And as I said, we're going to talk about some of these nested certifications. And then I want to talk a little bit about how not to fail, right? You've done all this great design work. You've done all this coordination. I want to just share a few lessons learned, some really common pitfalls and how to avoid them. So let's talk about pre-design. So really one of the most crucial things, right, when you're scoping out a project is really about setting the schedule, right? And understanding how some of the extra things that you have to do get folded into a typical design process, right? So you have to ask, when does the energy model get built? How does the energy analysis get integrated into the design process? And how much time is required for third-party QA/QC? So whether you're working with, whether you're working with FIAS or RDL or the Passive House Academy out of Ireland. Anybody work with them? You work with them? I worked with those guys on my first two projects, and it was great. I loved working with them. Mostly, I loved calling them and listening to their wonderful accents on the phone. But so this, what I want to show you right now is, right now I'm currently working on a 104-unit multifamily passive house in New York. And we just wrapped up schematic design. And this is like, actually part of that schedule, right? So just to use this as an illustration, right? So we had a couple of weeks where we had to do some redesign. We had to revise some units. We had to coordinate the fenestration. We had to have some time for some internal reviews. Then we had to have the client approve those changes. And then we had to distribute the backgrounds to our consultants, right? All this is very typical so far. And then we were going to get into the exterior development. We had some ground floor program that was commercial that we had to deal with. We have to look at materials, et cetera. So there's that exterior development component still. And then we have about a week to get that facade scheme approved. And then we were going to move right into the building section, wall section, pricing notes, et cetera, right? And you'll notice down in that list, it also says verify assemblies and systems in WFI, right? But as of yet, the schedule doesn't have any room for WFI. Come on, there you go. And so here, right, we've got to pop in, oops, pressed it twice. So here we have the WFI model, but you can see that the WFI model is scheduled to happen concurrent with the building section and wall section. And the issue with that is that the design needs to inform the energy model, and then the energy model needs to inform the design. And so when you're scoping out these projects, you need to make sure that you're really building in time for these kind of feedback loops that you don't have in a typical project where you might just be designing to meet code at a minimum. there are certain things that can happen concurrently, right? You can be cartooning out the set as you start to work on the Woofy model. You can be, doing other things like the roof plan, et cetera, that aren't really going to be affected by the Woofy model. But you really need to, make sure that you're not, you have some space in order to get that feedback and make sure you're integrating that feedback into the drawings. And so we're really recommend using Woofy or PHPP, right? It's the same. If I say Woofy and you use PHI, just think PHPP, right? They're both basically the same in this case, but we want to use both of those energy modelers as design tools, not just verification tools, right? And so the other really critical scheduling component is just how do you integrate the third-party QA/QC into the projects. And this is from PHMass's website, right? This is their current review queue. They're just a screenshot of part of it. Each one of these numbers, right, represents a project. Mine's somewhere in there. Unfortunately, not close enough to the top. Their first round of review takes them 6 to 8 weeks. It's a really long time. You can do an expedited process with them. Like I said, I've worked with Passive House Academy. I can't remember what their timing was. I don't know what RDL's timing is. And there's a bunch of, there's the certifier. So everybody's got their own timing, and it's just really important to know that upfront and make sure that it's going to fit into the overall project schedule, because something like this can really throw a wrench in it, especially when you're working for on like affordable housing projects. I've run into this a lot where we're waiting on confirmation and we can't, the developer can't actually close out the project and get the tax credits. Or get certain parts of that released until they get like the project pre-certified, right? And so it becomes this very intense and stressful time of push and pull as you're like, trying to get whatever certifying agency you're working for to get you final pre-certification or tell you what you're missing, so that the rest of the team can do what they need to do and start construction. So this is a version of the McLeamy curve. So the McLeamy curve, right, it basically says that the sooner in a design process that you make a change, the more impactful and the less expensive it will be. As you get further into design and even into construction, the less impact you're going to have and the more expensive that change is going to be. And so that's why we really actually recommend changing the design process a little bit. I'm gonna, so in a typical design process, right, we start with broad decisions and we work and we work and work until we get to more detailed decisions. And one thing that we find is that systems design tends to be one of the design decisions that kind of gets put off, right? Not till the end of the project, but till further down the line. And so what we recommend is really moving systems up much further up to the beginning of the project, right? And so right off the bat, we want to be talking with the developers and the design teams about their preferences for how systems are designed. And I'm going to just give you a really quick illustration about why that's important. So let's just talk about ventilation. Right, as you all know, ventilation is crucial in a passive house project. You might do centralized, decentralized, or semi-centralized. I've done all three of these. I don't think there's any one right answer. It really depends on the developer's preferences mostly. And that could be based on what kind of maintenance they want to do. It could be based on, if they want, who's paying the utility bills, how things are metered. There's a lot of different reasons to choose any one of these. But I want to focus on a decentralized system because that one definitely has the biggest effect. So, you know, decentralized systems have the advantage of being very simple, right? No trunk lines or fire dampers. You can, you know, there's definitely flexibility about where you can place them in the units. You might want to place them by the halls and access them from the hallway, or you might want to have, you know, an excuse to go into a tenant's apartment on a fairly regular basis to change the filters and make sure everything in the apartment's okay. Again, that's a developer preference. If you move that ERV to the front of the building, right, and decrease the distance that the ducts travel to the exterior, those units get a lot more efficient. And so what you start to see is that just based on the location of the ERV, right, you start to drive a lot of other things like fenestration. So the exhaust on a decentralized ERV like this, it needs to be 3 feet away from an operable window or door, and it's got to be 10 feet away from the supply. And so all of a sudden, what you typically don't see, which is the ventilation system, starts to affect what you do see, which is the fenestration, right? And that fenestration, as we all know, really drives a lot of the character of buildings in general, right? It's a major feature. And so I can't tell you the times that I've worked with a design team, and they've spent all this time making this beautiful fenestration pattern, only to tell them like, yeah, that doesn't work, you know? And so what we do is we recommend when we start working with design teams that they have this conversation up front. And the sooner you have it, the less redesign teams are going to find themselves having to do, right? Less heartache, less pain, less suffering, much less expensive to make changes earlier on as well, right? You can really start to see how that's going to start to drive the character of the whole building, just something as simple and unseen as a ventilation system. So once we get into design development, that's where we really start to test the assemblies. And so, as I said, we want to use these energy modeling tools, whether it's PHP or WFI. We want to use them as a design tool and not just a verification tool. And one of the ways that we do that is that we, we'll test different versions, and we'll see, what is the optimal amount of insulation, right, for any particular assembly, right? And we can see here that, there's very little difference in energy savings between 4 and 6 inches of insulation. However, 6 inches of insulation is going to be much more expensive to install than 4 inches. And perhaps we can find a way to make 3 inches, work on a particular project as well. By the way, just the B on these were taken from an actual project. The B is for the baseline. So that's where we started, an initial assumption of 2 inches. Then we tested 3 inches, 4 inches, 6 inches. We do the same thing with the roof, right? You can see here that there's very little difference between 24 and 30 inches. However, depending on what kind of roof it is, right? Maybe what we do is we back off on the wall insulation, right? We go, okay, 4 inches of insulation is going to be, of exterior insulation on the wall would be, ideal. However, it's going to be really expensive. We're going to need larger girts. We're going to need, different kind of support system for the cladding. So let's try to get that back to 3 inches, and maybe we can add more insulation in the roof, right? If it's just blown in loose fill. And even though 30 inches doesn't save a lot more relative to 24, it might be enough to, offset a loss elsewhere. So we use these as parametric design tools in order to, optimize the assemblies and then optimize everything as a whole. We do the same thing with systems too. In this case, we were looking at centralized VRF versus decentralized mini splits. And again, there's going to be, reasons other than energy that you might choose a centralized VRF over a decentralized mini split. Want to emphasize that there's no one right answer. What we're trying to get is to a balanced and optimized set of choices, for the envelope and for the systems that worked for the specific project. When we get into construction documents, this is just an example of the red line test. It sounds pretty simple. We often will do this actually in the field with builders. We'll get into CA in a little bit. But although it's a simple test, it's a powerful test, right? And shows you where you start to have problem areas. So this is an example of some clients we're consulting for. They showed us these drawings. The CMU stair core was breaking through the thermal barrier. And so, what we did is we just showed them how to wrap that thermal barrier around that CMU. And, in this case, it was a pretty easy problem to solve. Others are more tricky, right? And one of the things that we find as consultants, right, is that we can have conversations about sequencing, right? And I know that sequencing is definitely a gray area for architects when they're talking to builders, because it gets into that kind of means and methods territory. But as consultants, we can talk about it. And I was just talking to, tell me your name again? Zach. So Zach and I were talking earlier, and he was telling me about one of the things that they do on site is that they have these toolbox talks, right? Which is, so every week, right? And they're game planning out the next 2 weeks of work, all the subs. And in a sense, we do a similar thing when we're going through the design process with teams in order for, to think about things like constructability and think about things like sequencing and do, early design stage clash detection. And so that, and make sure that that those things are communicated in the drawings to the build team in the field. And so in this case, right, we're looking at like, well, what does continuous thermal barrier actually mean? And so we have, our sub slab insulation. We're insulating the inside and the outside of the stem wall. And then in order to avoid the thermal bridge of the brick wedge, we're insulating that with a foam glass block to create a thermal break there. Now, there's still somewhat of a thermal bridge in this detail, right, down at the bottom of the foundation, but we find that some thermal bridges, especially in locations like that, like the buildings can handle it. A lot of times you'll see those, insulation going around the entire, wrapping below the footer, which instantly makes structural engineers have heart attacks. And so we try to be nice to our structural engineers, and I don't want to be held liable for any structural engineering injuries. But anyway, we do the thermal bridging analysis, and we find that this works just fine. In other cases, right, we help the design teams, again, really think about sequencing, because it would be quite easy to actually like wind up with a dead space, right? It'd be very easy, like in this case, the drawings were calling for spray foam. But if you don't hit that spray foam at the right time, that area is going to be really inaccessible, and it's definitely a big potential to miss it, right? And then you just have a big cold spot that's going to have condensation and cause all sorts of issues during the life of that building. And so, in this case, we recommend insulating the entire parapet wall and doing it before the sheathing goes on, and making sure that the truss cavity is insulated to the same extent as the rest of the wall as well. right? So again, sequencing, responsibility of trades. That's the other key thing too, is when we're talking through a lot of these details, not, it's actually more unusual for one trade to be responsible for, like, say, the entirety of the air barrier. You often get, one trade doing one part of the air barrier, another trade doing another part of the air barrier. And so doing something like those toolbox talks and really making sure that each trade understands what their specific role is key. And I'll show you in a little bit what happens when that best practice doesn't happen. Another thing that we like to communicate to design teams is, just leaving space for things we don't typically think about, right? I've seen this get projects into trouble too. This is just a waistline or event stack. And and if you don't leave it, we're used to just like shoving them in a corner, not thinking about them, right? Oh, plumbing engineer will just, stick it wherever. But you really need to leave enough room around it in order to have space for the gasket and have space for the tape, because that is just penetrating the air barrier. And that's going to be a major weak point if you don't actually prepare for it and plan for it. This is just an image of like a row flex and a K flex gasket. The row flex is for larger penetrations, ducts or larger pipes, and the K flex is for electrical, smaller like electrical wires and whatnot. And then, so there's things like that where we're like, we want to go like hardcore when it comes to passive house, like the air barrier, we typically go pretty hardcore, make sure all the gaskets are there, make sure there's room for everything. And then there's other places where we know how to back off, right? And so entry doors are always a troublesome part, right? You can get passive house quality entry doors that are, meet ADA and egress requirements. They're really expensive and hard to get. So often what we do is we just go for like a pretty good solution, right? And so we've used Conair 451s, we've used 1600 UTs, we've used a couple other brands as well. And, these windows here, these storefront is actually all Intus. And you really can't tell, even if the picture wasn't washed out, you wouldn't be able to tell. You just have to trust me. But like a Conair storefront system, entry system just kind of blends in with the rest of it. And so you have to do a really good job weather stripping it. And you take a little bit of a hit on the thermal performance, but the buildings tend to be, we have enough room, with the metrics that, we can handle something like that. You can also, in this case, we use double pane argon filled IGUs, but you can also use triple pane. We've used in subsequent projects, bless you. In subsequent projects, we've used Alpen IGUs with their thin glass product that fit in a standard frame. So you're getting a triple pane window, but in a standard thickness that a double pane would fit in. And that's a great solution as well. So our goals for our passive house details are always to make them affordable, executable, and effective. And I'll tell you, when I first started doing passive house consulting, and I had only gone through the PHI training, which was an amazing training, absolutely, foundational. But a lot of those details are not relevant to the market that we're in. And so, when I would present these kind of European details to the builders, I just get laughed out of the room. And it was some hard lessons. But I continued to work with those builders to develop details that were affordable, executable, and effective. There's another project we were actually brought onto recently where the designer was kind of in the same place I had been a while back. And so basically that team had designed a building that use these TJIs, big outrigger TJIs. The structural wall was 2x6, and then they use these big outrigger TJIs to contain all of the insulation that they thought that they needed, right? However, once they brought us on, we built the energy model, and we said, hey, we can actually get this down to something much, much more standard. So just a typical 2x6 wall, dense packed cellulose, 2 inches of exterior mineral wool insulation, right? And so it's really about, knowing when to push and be hardcore about, what it takes to achieve passive house, and knowing how to pull back and how to optimize and make something affordable and effective, right? So once you get into construction, right, we've got the verification process. And, so why do we do verification, right? Well, it provides project QA/QC, it validates the design decisions. It verifies the performance goals are met, right? And that it's going to function as intended, right? There's a certain aspect of commissioning to it. And it confirms that the building construction matches the drawing specs and energy models, right? So I know that the developers here, you go through all this trouble and expense to get a project designed. You want to make sure you're getting what you paid for, right? And so the verification process really helps with that. There is, sometimes some overlap with typical CA, but it really is more in depth as well. And I would say that it mostly complements typical CA. And so in that verification process, right, there's going to be the assembly documentation, there's checklist completion. We'll talk a little bit about what the nested certifications, and that's where the checklist comes in. There's some contractor certifications that always tends to take people by surprise a little bit. It's not a big lift, but it does, if you're not anticipating it, it can be an issue. And then there's the testing regimens, right? So you've got the envelope air tightness, duct tightness, and ventilation balancing. So the verification timeline, it actually starts during design, right? So, and this is, again, this is actually specific to PHMass. So if you're working with a PHMass rater or verifier, right, you want to bring them in early if you can, and have them review the design just as an extra kind of QA/QC. They might have some insight in regards to the testing and verification that they're going to have to do later on, and can help the design team to streamline that process. And then there's the slab foundation, slab and foundation installation, right? And that's where they're going to photo document that there's the right amount of insulation before you pour the slab. If you pour the slab, you don't have any photo documentation of the insulation underneath, that's a problem. And that's gonna, you gotta dig it up. You might find Jimmy Hoffa. You might, you'll at least find hopefully enough insulation. So one of the things that we say, even though the verification team and the design team are separate, so there's not a whole lot we can do as the passive house consultants. However, we do emphasize that the builders, if possible, should really just take as many photos as they can, kind of all the time, just as a precaution, just in case anything gets missed. Inevitably, you're going to need one of those photos. So there's the pre-drywall site visit, and that's going to verify the insulation has been installed correctly. There's a pre-fenestration lower door testing. So this is an ideal scenario, right? It doesn't always happen this way, but ideally, if you're building, and again, it's going to depend on the type of the building, but if you can build the building, have everything, have all the doors and windows framed, but sheath over them, and so then you can come and do your first lower door test, and then without the doors and windows installed, or you obviously have, one or two doors installed, but that really helps minimize the places where leaks can occur. So it makes leak chasing much easier. And then you do a follow-up test once all the windows and doors are installed. And again, it helps kind of minimize the leak chasing. In some ways, that represents an ideal process. In other ways, it certainly adds cost and complexity. Regardless, we recommend not wait until the final blower door test to do your first one at any rate. So you have duct leakage testing, you have the balancing of the conditioning systems and the ventilation systems. And then because if you're doing a FIAS, right, you're also doing Energy Star, and Energy Star requires compartmentalization for multifamily homes. So that's where you're testing the air tightness between the units, right, as opposed to the whole building. And then you finally have the whole building blower door testing. And then there's some, final kind of wrap up with the workbooks and checklists. Again, this is just to kind of emphasize the final blower door test is optional, but we don't recommend waiting. So what do these nested certifications look like, right? So for a single family to 5-story multifamily building, in addition to Passive House, you're also going to get certified with Energy Star, EPA Indoor Air Plus, and DOE Zero Energy Ready Homes. If you're doing 5-story multifamily with centralized systems, the only one that you're doing in addition to FIAS is EPA Indoor Air Plus, and same thing with 6-story multifamily and commercial.
Excuse me,
yes.
when you say centralized system, are you talking about ventilation or mechanical system?
Both. I'm not sure what the threshold. I'm not sure what the
heating and cooling
Heating
system
and
as
cooling.
well, or
Yes.
just?
It would be a whole centralized system. It would be both heating, cooling, and ventilation.
But not necessarily hot water.
Hot water is treated differently. So this is really just about the delivery of either fresh air or conditioned air. But we'll get into hot water too. Hot water, there is actually another certification, which is WaterSense, which is going to come up in a minute, and that's only for residential projects. So, here you can just see the list of the tasks that are required for each one. And really, when you do a Passive House project, really almost regardless of whether you're doing PHI or FIAS, you are hitting all of these benchmarks automatically, right? All of these other systems benchmarks automatically. You're going so far beyond Energy Star. Like when I first started consulting on Passive House projects, right, we actually had some conflicts where, particularly around ventilation, trying to remember like what they were. There was stuff around like kitchen ventilation and bathroom exhaust, and we had to work really hard between the agencies to basically get like Energy Star to say, oh yeah, if you're doing Passive House, it's fine, right? You're going way beyond what we require. And so there were several things like that happened, and those are really mostly smoothed out by now. It's like MERV 8 filters, right? You use a MERV 13 at least in a Passive House.
Pre-slab inspection.
Yeah.
Air Plus, what is that?
The pre-slab inspection so Indoor Air Quality Plus, that has a lot to do with actually like material toxicity. In this case, the pre-slab inspection is referring to radon mitigation. So if you live in radon zone 1, you automatically have to put in or at least a passive radon system, and then provision for it to be active, right? So you have to put in all the piping, have it, piped up through the roof, and then have at least a place for a fan to be installed after construction and testing is done, and power for that fan. So that's what that's why that's that's why there's a pre-slab inspection for Indoor Air Plus. And so, yeah, there you go. So there's a pre-slab inspection, right? They're just measuring the depth of the insulation. The pre-drywall inspection, right? You need to have a grade 1 installation. It's harder to say than you think. And that means, there's no gaps, there's no, nothing's tucked under. That's like for like a fiberglass or any kind of batt insulation, it's pretty rigorous. It's one of the reasons why we actually like to do blown-in cellulose. There's other reasons for that as well. But it takes some of the, it just solves a lot of the problems that kind of end up coming up when you're trying to get to a grade 1 installation. And then we do thermal imaging as well. This is my colleague Angela doing some verification on a project, looking for thermal bridging. And so when you're doing Energy Star, right, that requires a HERS rating. And that requires another energy model. That's a REM rate energy model. So in addition, in this case to WFI, you probably aren't doing it if you're using PHPP. HERS is kind of great in a lot of ways. I mean, it's kind of a benefit. We were talking, tell me your name again, I'm sorry. Kent. So Kent was telling me that his projects also have LEED for homes ratings, which is great. And I think we're seeing some of these rating systems get reflected back in the real estate market. I'm super interested in that talk because it's definitely one of the weak points, right? It's like we do all this great work, and then real estate professionals, like, they don't care. They're like, they don't know how to value all of this incredibly valuable work that we do, right? But so, we do see HERS sometimes get reflected in real estate, and and LEED for homes is similar. So basically it's based on a typical score of 0 to 100, right? 100 is based on the 2003-2006 IECC. Passive houses tend to be somewhere around a score of 30. And that assumes no PV. Let's see. So for Energy Star, right, you are going to do a blower door test, as I mentioned before. That requires a compartmentalization test. And so that's when you're in a multifamily building, right? You're testing unit to unit as opposed to whole building. It requires an energy model, a different energy model. It requires a HERS certified professional, right? So that's one of the differences. Sometimes you hear FIAS rater versus FIAS verifier. The FIAS rater is also qualified to do the Energy Star rating and model building. And so the credentials that I mentioned, right? So the HVAC contractor for Energy Star, this is always a little sneaky one. They do need to get credentialed by the ACCA or Advanced Energy. I think there is a charge for that one. Yeah, it's about $1,500. And then the general contractor has to register as an energy partner. There's a free training and there's no other charge on that. For EPA Indoor Air Plus, that actually is sort of like Energy Star is nested within that. So that requires Energy Star. It's going to deal with moisture control. As I mentioned, there's radon issues that it looks at, pest screens, there's some HVAC requirements, and there's low emitting materials, which is great. I actually think this is great. One of my complaints, like it's kind of the best and the worst thing about Passive House. On the one hand, I love that Passive House tells you where to go, but not how to get there, right? It gives us lots of freedom as designers. But on the other hand, when we're really thinking about sustainability and thinking about using this as a tool to fight global warming, we could either be doing more harm than good, or just not be doing as much good as we think if we're not using good materials, right? And so Indoor Air Plus kind of provides some guardrails for the materials that get chosen on a project as well, and I think that's a real benefit.
Is that changing right now?
How so?
I thought there was like a new version.
It might be, and I'm not, I'll have to look into that. I'm not sure. Do you think in the new version, are they less concerned about materials or more concerned, or what do you think? Way more concerned. Oh, that's good.
Well,
Maybe. I guess we'll see.
yeah, more in the direction of lead, which is a lot of paper, but I don't know.
Okay. Yeah, I'm not sure. I have not heard about that. So zero energy ready homes also requires Energy Star. It requires EPA Indoor Air Plus. There are prescriptive RNU values, which you just blow out of the water doing passive house. So, we never worry about them. You have to be PV ready. Makes tons of sense. If your project doesn't use PV, even when we're working on projects that aren't going for passive house, we always make sure we're putting in the conduit, make sure we have space at the electrical panels for PV to be installed in the future. And then water sense. So water sense is only required for residential projects. And there's a calculator from the EPA that's used to determine the maximum hot water run lengths. Basically, you need to get 0.6 gallons are allowed to flow down the drain before the water temperature increases 10 degrees Fahrenheit, right? And it's not that it's that hard to do, but you do really have to get your plumbing engineers on board early and make sure that they're filling out the calculator. And, of course, with whether it's PHPP or WFI, you're doing a ton of plumbing takeoffs. And so this is one of those sneaky little things that is actually really easy to screw up if you don't know about it ahead of time. And so this is something that we always make sure our plumbing engineers are very, very aware of. So systems testing, right? We have ventilation rates, ventilation and heating and cooling rates. So I think the big thing here is that the actual built systems need to be within 15% of the design rates, right? And that the exhaust and supply rates need to be within 10% of each other. That's really, I guess, the way that you design for that, right, is by making sure that you have either sufficient, let's say it's a residential unit, making sure that you have the doors undercut sufficiently. That gets into some acoustic issues. So, do you do transfer ducts, right? And is that in the ceiling or is that in the walls? And really making sure that you're, you have enough airflow or the ability for the air to flow from room to room in order to achieve these rates. Again, it's not rocket science. We say it's not rocket science, it's building science, right? And as long as you provision for it up front, it's actually very reasonably easy to do. Duct leakage testing, right? You're probably all familiar with aero barrier. That actually it's a spray product that was designed originally to seal ducts, make them tighter. That's still a great kind of get out of jail card, although it's not cheap. But if your ducts are really leaky, or even if your envelope's really leaky, you can call those guys from Aero Barrier, and they can make any system or envelope tighter with that product. Fortunately, I've not had to use them, but I know they're there. Bedroom pressure balancing, this is what I was describing in regards to door undercuts or transfer ducts, and then again, hot water testing. And then finally, right, and this is just for PHIAS, I didn't put up the PHI metrics, they use a different metric. They, they use air changes per hour. And they have two different, I think one of the things that people tend to miss, right, and it's always kind of bothered me, there are different testing standards when you're doing PHI for larger or smaller buildings, right? Like, I feel like PHI often gets unfairly criticized for using ACH, and that because if you use the normal, I think, I can't, it's been a while since I've done it, so I'm forgetting the exact term. But if you use like the normal testing protocol, your building can look tighter than it actually is if it's a larger building. And so there's two different testing protocols, and you just have to make sure that you're using the right one depending on the size of your building. I guess the CFM 50 per square foot of envelope, that tends to scale a little more readily. And so that's why PHIAS adopted this one. But you're really getting to similar places. Here, you can see my colleagues actually doing some air tightness testing. And here, one of my colleagues is working with the contractor, and they're using a thermal camera to actually find the leaks in real time. And so like here, you can see this purple area represents a thermal bridge, right? As opposed to this area where it's wispy, which actually represents air leakage. And so by using that thermal camera, we can find the leaks in real time, we can patch them up, and we can watch the building actually get tighter as it's under pressure. The other really cool thing about that actually, and this has happened several times, we'll often loan our thermal camera to the contractors, and it just kind of becomes like a game. Like, I think people just like new toys, tools and toys. But just to see the excitement of like, it's like all of a sudden they have like X-ray vision, right? And they can, find all the leaks, and it turns into a game. And then they're finding more than they even need to find. So in summary, right? For verification, best practice, you want to include requirements to specs, you want to engage your radar verifier during design. Note the differences between PHI and PHIAS. It's probably something you want to do early on because it might actually help you determine which system you want to use, right? This is really key, right? Determine which certifications are required for, prior to bidding. Because, you don't want to, hire, or have your GC hire a sub, say the ventilation contractor who didn't realize he has to go through a training and, pay a couple extra bucks and register with Energy Star, right? We don't want to surprise anybody with that. So make sure all that stuff is disclosed early on. And then, test early, test often. So lessons learned, right? You've done all this time, right? Your team has worked really hard. And you have a passing pre-certified energy model. You want to keep it looking like this. You don't want construction to turn it into that, right? And it is unfortunately easy for that to happen. And like, I don't want to, there's builders here. I'm not putting any of you down, right? Because my job is way, way easier than yours. But like the construction process is frankly the weak link when it comes to building passive houses. And it's not because the builders are bad, far from it. It's because they have the most challenging job of all, right? They're out there in crappy weather. They're out there in all sorts of conditions. It's super complicated. I'm sitting in my office with a cup of coffee, drawing pretty details, right? And so I'm giving, so this information is not to trash contractors at all, but to just help everybody avoid some common points of failure where people get tripped up. So as I said earlier, right? A lot of times, like what'll happen is you get subs on the project and they just don't understand how what they're doing fits into the larger whole, right? They come to the site, they're doing their thing. And like, so this was one of my first couple passive house projects. And we had a bunch of extra sub-slab vapor barrier. And the intention was for that vapor barrier to extend over the stem wall and then wrap up and get attached to the sheathing, right? And be part of that primary air barrier. So the masons showed up to the site in the morning and they said, hey, what the hell is all this extra vapor barrier doing here? And they cut it off. Then they put it in dumpsters and they wasted a ton of material. And then they poured the slab and we had nothing to attach to the primary vapor barrier on the walls. And so the way we fixed it is we used Prosecco fluid applied flashing and painted it a couple inches onto the slab up over the sill and about, I don't know, 18 inches or 2 feet up the wall. It did the trick, right? But it was expensive, it was time consuming, it was super annoying, and it was a super, super, super valuable lesson in communicating the entirety of the design intent to every single sub. That's why I love that story you told me about doing the toolbox talks, right? And making sure everybody knows how their small part fits into the greater whole. Another thing to do is to set standards, right? Show the contractors what a good tape job looks like. And again, this isn't meant to be insulting. It's just to make sure that everybody is on the same page and speaking the same language and that there's a visual representation of a standard that should be met. Because I've seen this so many times. This is another passive house project. This was fixed, but like this never should have happened in the first place, right? You see all these giant gaps in the sheathing, there's tape peeling, the sub-slab vapor barrier has been completely abused and degraded. Unfortunately, it's more common than I care to admit, but it's what we try to avoid by talking about it up front. Another thing, right? Designate responsibility for the air tightness. Something that we've started to implement actually is doing, and we didn't used to do this, but I find that it helps a lot, is to do a schedule of penetrations, right? So just like we do a window schedule, and a door schedule, and equipment schedules, we will have a schedule of penetration. So for every time a conduit, a duct, any kind of plumbing pipe, you know, radon, whatever it is, anytime something is going to penetrate the air barrier, we have that in the schedule, and we know how it's going to get sealed, right? And we know who's going to do it. Now this is really tricky, right? So this is a true story. I'm gonna change the names to protect the not so innocent. But substitutions will get you in trouble, right? And substitutions always happen, right? So the message here is not don't let anything get substituted because it's just not reasonable. The lesson is be extremely careful, and here's why. So we had specified this super sweet passive house certified Swagon Gold RX unit. And you know, we're meeting all the benchmarks. It was terrific. That's the way the project was bought out. And then during construction, the contractor wanted to make a substitution. Now, the real issue here was that the architects didn't consult with me before they accepted the substitution. So, and it took them a little while to admit that. That was a little bit of a surprise when they finally were like, oh, this isn't a substitution request. We've already accepted it. That was a problem. But, so at any rate, so once I found out that they did that, and I would, this process doesn't change regardless of whether they did it or not, but the first thing you have to do when you're looking at a substitution is figure out, you know, does it have an AHRI certificate, or is it certified by Passive House? This is for a piece of ventilation equipment. Because if it's not, right, we have to derate that equipment by 12%, and that's instantly going to kill the model, right? That's going to kill the project right there. So in this case, this unit was working on getting its AHRI certificate, but it didn't have one yet. And if you've ever had to deal with AHRI, it's like totally black box. They're just like, yeah, it's coming. It's still coming. Yeah, it's like you cannot get any information about an actual timeline. Anyway, it finally did get its AHRI certificate. We were okay. It was less efficient than the Swagon. And so we needed some additional solar panels. So then the next question was, okay, well, how many do we need? And do they actually fit on the roof? Turns out the additional solar panels fit on the roof, but how much did they cost? So the new unit, the substituted unit, was $20,000 less than the specified unit, but the additional PV cost $70,000 more. So that was a $50,000 add to the project. So what we wound up with was a pissed off owner, a very sad architect, and a very happy builder because they just earned their bonus, right? Now, one of the things that we realized was that, the architect frankly had some disincentive to consult, right? Like they have a fixed fee. I think at this point in the project, we were probably hourly, but we could have saved them a ton of pain and suffering if they'd paid us for the couple hours that it would have taken to vet this piece of equipment before it was substituted. One other story I want to tell, again, true story. This is where the builder in this case just didn't give us a submittal. This was a project we were actually the architects as well on. The owner didn't give us a submittal, and our intention was that there were these ICFs that had about two and a half or so inches on either side of EPS insulation. And in their builder was very generous and bought ICFs with an additional 4 inches of insulation. So it was like 6 inches of insulation instead of 2 inches of insulation, right? If they just given me a submittal, right, I could have saved them like, I don't know, at least $10,000, maybe more. If they just taken half an hour and given me a submittal, and I would have, not approved it, and they could have bought the right thing. But probably even more critically than this is that having too much insulation could have killed the entire project. So on a multifamily building, right, the limiting factor is often the cooling demand. And you can see here that the cooling demand, right, it increases. Here it is with the ICFs as designed. Here it is with the ICFs as built. And the cooling demand increases from 6.89 kBTU to 7.11, and our limit was 7.2. So we just squeaked in under the wire. But you can actually have too much insulation, right? Too much of a good thing on some projects. So I want to wrap up with this. This is some old data, but I think it's still relevant. This was actually compiled by NK Architects and Onion Flats with data from PHFA, the Pennsylvania Housing Finance Agency, which really kicked off, I think, the great work that we're seeing here in Massachusetts, and by including Passive House in their QAP. And basically, I've got 2 of these projects are mine actually. But so this shows in their first batch of passive houses, passive house projects versus non-passive house projects that they funded through tax credits. And the blue squares are passive house, the white squares are non-passive house. However, if they weren't colored, you couldn't pick out which ones are passive house or which ones aren't based on the price of the projects, right? Some are more expensive, some are less expensive. In general, there was about a 2.5% increase premium for passive house projects. This, by the way, was based on the 2009 code, which is terrible. right? Like it is so much easier to hit passive house these days with the code the way it is, versus when we were doing it on the 2009 code. And this was everybody's first passive houses, so we felt really good about a, average 2.5% difference. Some are of course more than that, but on average, really reasonable. And then the next year, and this was a surprise to all of us, the passive house projects were actually less on average than the non-passive house projects. But the same thing applies, right? Some are more expensive, some are less expensive. You can't tell just by looking at price. And that trend held true for the third round of funding as well. Now, what this tells us is that two things. One, two passive houses cost more. Well, if you're using more insulation and you're using equipment that you other like ERVs and stuff that you might not use otherwise, and yeah, they're going to cost a little bit more. However, there are many, many, many other cost drivers to projects. And so passive house, what this data tells us is that passive house is not going to be the major cost driver to these projects, and that you can deliver passive house projects at market rate and comparable to non-passive house projects. So just to sum up, right, we took a very quick and very broad overview into integrating passive house methodology into the design and construction process. We talked about scoping and scheduling, energy modeling, iterating, third-party QA/QC. We talked about the typical design process and how and why to reconfigure it. We talked about assemblies and system optimization. We talked about detailing, sequencing, and right sizing. And then we got into CA and talked about all the nested certifications, a little bit of detail about the verification process. I think really critically, common pitfalls and how to avoid them. Got a ton more. I actually do an entire presentation just on them. All of these things are actually almost their own presentations. And then we wrapped up with a cost comparison. So I hope that this information was useful to you. And I'd love to answer some questions. So thank you.
We have plenty of time for questions, so feel free to jump in. Anyone raise their hand?
Can you explain what exactly is encompassed in the HERS rating? I mean, besides unit compartmentalization.
So a big part of that is the energy model. And so that uses a particular software called REM rate. And so you need to build an energy model. I've actually done it, although I'm not a HERS rater. I have used it before, although it's been a while. And it's similar to both like WFI and PHP in a sense. I mean, it has kind of slightly different parameters, but it's still looking at, glazing parameters, wall parameters, solar exposure, shading, use. It's a little bit, in some ways, it's a little less sophisticated than either PHP or WFI. I feel like it's a little bit broader, but that's one of the primary other components of it. Yeah.
Similar to how you came up with a typical HERS score for a passive house building, do you have a typical EUI for a passive house building?
I don't, and that, so the EUI, I don't know off the top of my head. I mean, I would probably, we could figure that out pretty easily just by looking at, our different WFI models for different building types. One of the interesting things about PHMass at this point is that they have changed, like since 2015, they've changed essentially they've changed the algorithms really significantly. So in 2015, so prior to 2015, the FIA system was the exact same benchmarks as PHI, right? And then in 2015, they introduced site-specific criteria, and that actually changed the heating and cooling demand and load benchmarks. And they implemented a kilowatt hour per person benchmark for primary energy as well. And then in 2018, they added, what did they add? They added, let's see, they did site specific, and then I think maybe it was program. They added program, or no, building size. That was what they added in 2018. And so they added that to the algorithm. And all of a sudden that changed everything. And so that also changes the, basically the EUI target at any rate. And then in 2021, on top of all that, they added building use, which changed things even further. And that in 2021, that really affected the primary energy target. And so while I don't know the number off the top of my head, you know, I think if we went back and looked at the, different models that we have, you know, I think we could probably get some reasonable comparisons, but I'm just not sure right at the moment. I do think that you know, it does make it a little hard to compare passive houses across the board. But I also think that there's a lot of good logic in some of the changes that they've made. So for instance, like, why should a small building have the exact same, you know, heating and cooling demands or limits as a large building, right? When it's so much easier for a large building to, you know, retain its thermal energy, and there's so much less surface area relative to its internal volume to lose that thermal energy, right? So I think a lot of the changes that they've made actually make a lot of sense. Other questions? Yeah.
So we've been, in Massachusetts, we have a lot of passive house work going on, as you know. And we've had some criticism of the idea that the final certification process through FIAS and FEE, but maybe perhaps more FIAS, we're not quite sure, takes inordinately long. And this is an issue for developers as they're building this into their financial models and stuff. Have you experienced that? What are your thoughts about that? And to what extent might it be tied up with all the other certifications that come with FIAS? And how they're layered on and achieved?
So the answer, yes. Yeah, I mean, it does take a long time. I mean, and I've certainly seen part of that, you know, be a result of like some of the final, you know, so all right, I guess I'm of two minds of it, really, right? On the one hand, sure, it's a giant pain in the ass because it takes longer. On the other hand, it's an important check and balance, right? I mean, I've had it happen on my projects where the rater is, you know, basically doing a final post-construction check and verifying everything against their HERS model, right? And like calling me up, you know, construction's been done for months, owner's in there. And, you know, I'm getting calls from the rater saying, hey, I'm noticing this discrepancy, and then we gotta like work through it, right? And, you know, fortunately in those situations, you know, it's, you know, everything's ultimately been fine, right? But so it is a pain and it does take longer, and yet at the same time, it's an important QA QC process. So it's like talking about commissioning of systems, right? I mean, we know that we can't just install a, you know, a VRF and expect it to, you know, it's not plug and play. And passive houses, you know, are not really plug and play either, right? They need, they're complex assemblies and systems that need startup times and they need to get tweaked. And you need to make sure that the owners or occupants know how to run them. You know, the bigger the project, obviously, the more complex all that is, right? A single family home is a lot different from a multifamily home with, you know, big centralized systems and whatnot. So at any rate, it's not a great answer, Hank, but like, you know,
I want to reframe it a little bit.
yeah,
First of all, I'm hoping that we may have recommendations for checklists and procedures that can minimize the extended periods of time involved in these various certifications. And I want to pinpoint that by saying, we specifically in our new stretch code
Mhm.
have set it up so that passive house occupancy permits are not determined by a certification.
Mhm.
They're determined by the CPHC attesting to the building inspector that this project will achieve certification.
Mhm.
And that's a bit of a jump,
Right,
but it's critical because if building certification were to be required for an occupancy permit,
Mhm.
nobody could do it. Because
Yeah.
the times involved, you have
Sure.
occupancy for 8, 10, 12 months. And
Yeah.
that can't be allowed.
yeah. No, I think, you know, and I mean, I think the other thing that, I guess it's, one question I have is like, how do you make sure that the projects get certified, right, if that's a requirement? I know that when PHFA started to require, like when they initially adopted Passive House as part of the QAP, you really only had to achieve pre-certification. You had to do everything in your power to get to real certification, but if like, let's say you failed the lower door test, as long as you weren't like negligent, you know, they let you slide. Now they've changed that. You actually have to get real certification. And my fear with that was that, you know, it's gonna scare off developers and people were gonna do less passive houses. You know, and in a sense, I'd rather see more passive houses, like even if you miss the blower door test by a little bit, you still have an amazing building, right? And so, you know, I guess I'm kind of of two minds. I think that, you know, what you're doing here in Massachusetts makes tons of sense, right? You can't hold up a CO, because of certification, right? It's just not reasonable. What we do, you know, kind of as I described, is just to get in front of it as much as we possibly can. And, you know, and we do that by, you know, working with the verification team early, by asking the developer questions early, you know, doing what we call the OPR, the owner's project requirements, which captures a lot of this information. When we're consulting and working with other design teams, you know, we'll go through, as I said, I mean, all of these sections that I just went through are really they're all their own presentations. And so there's a lot more detail that we do get into, you know, in order to streamline the process. And, you know, we've gone through it a bunch and that certainly helps.
Yeah, we're very interested in whatever can be done to help new practitioners get through this. Because one thing we know is that with the incentives we have in our new code and the incentives we have in our Massive program, that we're gonna have dozens of new practitioners
Yeah.
taking on passive house projects.
Yeah, one of the things that we've done in Pennsylvania to help with that is where, you know, if you're doing a PHFA project, you actually have, in order to be the CPHC or D, you have to actually have a certain number of certified projects. If you don't, you have to hire someone, you have to contract with someone who does, and they provide oversight. So we've actually played that role a bunch of times, where a firm with less experience, they're the lead consultants, But they hire us to basically look over their shoulders and help streamline that process.
That's a PHFA.
That's a
requirement.
PHFA requirement, yeah.
Yeah, I'd like to see that.
Just a follow-up question to this, what percentage of your projects have failed because of the final rule testing?
I think we only have one. I think we only have one.
And that aero barrier, still has been able to help?
We haven't used that. But I have heard from other architects who have used it, and it's been really helpful. I've actually heard from some architects, I was talking to some architects in New York a couple of years ago. And they were looking at using it as just like their first, instead of their fail-safe, like the first thing that they do. So they really liked it. Yeah, Bev and then you.
I'll say there's two that have failed in Massachusetts. One was podium, very tricky. Podium's tricky. So if you're doing a podium project, make sure to ask other people in the community how they did it and what the best ways are, because it can be tricky. Really close, like, in fact, I think the PHI overall number, they would have passed, but not the inspection.
Uh-huh.
So, and then one was an architect who said they knew what they were doing, and somewhere in value engineering, like 200 windows show up on site that are double glazed, double hung.
Oh.
So something.
Yeah.
And yeah.
Yeah.
Just one more question though. Are you starting to see builders starting to get in-house capacity for blower door? Because I know of a lot of it, you know, sort of word of mouth things
Yeah.
where a verifier came in unexpectedly and like saved the day because they did an
Yeah.
extra blower door.
I just heard my first one tonight. We were chatting sorry, Zach's company, they have their own in-house blower door person, but that's the only time I've heard that from a GC.
I had a project where they had,
Yeah.
wasn't the final verification, but they were doing it. I'm sure it
Yeah.
was.
I'm
I
sure
think
we'll,
the compartmentalization, especially if like who's installing the windows turns over and they don't get the detail, right?
I mean, it makes tons of sense.
Yeah.
I mean, to just be able to have the flexibility as a contractor to just do that really fundamental test, like as much as you need to, you know, it makes tons of sense. You had a question?
Yeah, this is about, you talked earlier on about shuffling priorities in the design
Yeah.
stage. If I got this right, programming, systems, massing, then envelope. Specifically seeing a lot more larger buildings go the passive house route, particularly for the code compliance for it. And those larger buildings are often design assist jobs rather than design bid build. So we have a lot of parties on the job who are very eager to know what are the envelope performance metrics we need to meet,
Right.
that we need to carry like from the get-go
Yeah.
of design assist stage. And we haven't even had, I'm an enclosure engineer, so we haven't even had a mechanical design narrative presented yet on the project. And those are the sort of things where, you know, if they haven't decided whether they're going with a centralized or distributed configuration, why are we even messing around with different envelope inputs of changing a U factor by 0.05 or something when that mechanical setup is gonna swing the Wi-Fi passive results way more? And so I guess, how do you manage that with the team, both of design assist contractor and developer and owner and architect, who's kind of making sure to get everyone in the room, but then at the same time, you're building this model and trying to present, okay, these are the ones we should carry as a baseline. But we can't really verify that yet until we have our building really set up in the model.
I mean, yeah, there's a certain amount of work that has to get done before, you know, building the energy model is really worthwhile. You know, you can get to those, you know, I mean, you don't, you know, at least with like the FIAS calculator, you know, you can get to the, well, I guess the envelope airtightness, you always kind of know right off the bat, that doesn't change. You know, when I showed the slide about, you know, shifting priorities, It's not so much that we're designing the systems that early as much as we're talking about them and, I guess we're starting the design process, right? But it's not like, you're clearly like, you're not designing the whole ventilation system before you've massed out the building.
Yeah.
Right? But you're having the conversations early, you know what the contractor's preferences are, you're giving them a range of options and telling them the pros and cons, like you could do it. There's 6 different ways to do it. Here's all the pros and cons. What's your preference, right? And then once the design team has that information, then they can start to factor that into the rest of their design process, right? We do like to see it get more detailed sooner than later, because like I said, it does really start to affect a lot of the things that you see. But yeah, it's, it's like any design process, right? There's some things you have to do all at the same time. Some things are more sequential. Sometimes you go back and redo, you inevitably have to redo something because something changes. I had one passive house project where like literally at like the 11th hour, like everything was done. The project was actually pre-certified and they changed from a semi-centralized ventilation system to a completely decentralized system. And, that was pretty aggravating. But the contractor can convince the developer they could do it cheaper. So we changed everything, So anyway, it's really just like best practice is to try to get some of that more technical information that has a big effect earlier on in the project.